Hi everybody, welcome. Hi everybody and welcome. I am doing this video to support you with asynchronous number 10 so that you can kind of fully focus on the mini final. So what is asynchronous number 10? So if you pop it open, it gives you a little scenario. You are in a lollipop eating contest. You're given some humongous spherical lollipop with a volume of 2,400 cubic centimeters, so it's not so huge. The first contestant to lick their way to the center of the lollipop is the winner, and you have been practicing for months in this contest and have found that as you lick away towards the center, the rate that the volume of the lollipop changes, forgive me, um, in cubic centimeters per minute can be modeled by a function. So what is this function? Well, let's go back and see what it just told us. The rate that the volume of the lollipop changes is this function. And they're talking about it changes cubic centimeters, the volume per minute. It's given by this function. So this right here, everyone, a rate function. And I'm also wondering if my Zoom can help me here. Actually, I have some wonders. That way I could use the annotation tool. See if this works. I'm actually not on Zoom. I'm actually on QuickTime Player. But anyhow, there we go. So this right here is a rate function. And rates are important because we know that the area under a rate graph gives me accumulation. But we want to know like what specifically are we accumulating when we're talking about this problem. Okay, step one says use Desmos to examine this graph during the first hour of the competition. Is K of t positive or negative? Is K of t increasing or decreasing? Well, you're going to stick this onto Desmos and you're going to figure that out. So you're going to find out what this graph looks like. I don't know if I can copy and paste it, but that's your first step is to just go ahead and graph it on Desmos, this rate graph. And let's see what it looks like. So that is, it looks like it's in the negative range. And remember what this rate graph represents. If we go back to the problem, it is representing the rate that the volume of the lollipop changes. So, and we also want to verify that we've written that problem correctly. Minus 1/8. Oh, there we go. This is actually 1/8. My bad, friends. There we go. That looks nicer. First off, verify. It looks like a parabola-y looking thing. And this function isn't indeed kind of like overall after 8, input of 8, the function starts to just decrease forever. It would make sense that it's decreasing because as you lick the lollipop, the volume goes lower and lower. So negative slope as well, negative values. Because the rate is decreasing, we'll have a negative rate. Is making some sense. So just sense make as you're looking at this graph. And also just verify that everything is accurate. So you're going to go ahead and answer these questions, which you can definitely do. You're going to interpret what the input means, what the output means. So what do the T's represent? Again, if you're stuck, just look back at the problem description. It gives information. Next, it says interpret this expression, y'all. There's an integral in front of my rate function. If I take the integral of a rate, do y'all remember what happens? What do I get if I take the integral of a rate? That was that thing we were talking about in class. So this is my hint to you. We talked about the integral of a rate being accumulation. Now, what is the thing that is getting accumulated here? Again, if you look back at the problem, it'll give you some information of what's accumulating. Don't forget to interpret what the 0 and the 10 would represent. And if it helps, hey, you could even sketch the area under this curve and try to interpret um, how that area would be represented in this problem and what it means. And then after that, your last question, number 3, according to the function, how much of the lollipop will remain after 10 minutes is the question. So that is a little guidance for this async. Hopefully it helps. Try your best. This is just an attempt. I want to see what you all think. And yeah, so let me just get out of here.